Okay, today we're going to talk about exponents and the order of operations. So we've talked about exponents before. We've talked about the order of operations before, but there's never been exponents involved. So now we're going to learn what exponents are and then see where they go in the order of operations. So the first thing we have to talk about is an exponent. It says you can use an exponent to show a product, right? And let's think about, I feel like sometimes we read things and don't really understand what we're reading. So let's think about it. That's the answer to a multiplication problem. Okay, so you can use an exponent to show multiplication of equal factors. An exponent tells you how many times a number or base is used as a factor. So right here where we have 5 to the third, what that means is 5 times 5 times 5, which is 5 times 5 is 25, 25 times 5 is 125. And a couple of key things, 5 is our base, and 3 is our exponent. And so the exponent is telling us how many times this base is being used as a factor. So because it's 5 to the third power, 5 times 5 times 5 is 125. And a number that can be expressed using an exponent is called a power. So the number of 125 is a power of 5 because it can be written as 5 to the third. So let's look down here where it says write using an exponent. So 6 to the third, 6 times 6 times 6 would be 6 3 times. Okay, and we have to make sure that we're reading the directions. It doesn't ask us to simplify it, it just asks us to write it using an exponent, right? So we don't actually have to work that out. Here I have 2 being used as a factor, 1, 2, 3, 4, 5, 6 times. So that's going to be 2 to the 6th power. On this next one, I have 8 being used as a factor, 1, 2, 3, 4 times. So that's 8 to the 4th power. So now here's where we're going to start simplifying. Okay, so this is PEMDAS, but it's written out in a little bit more of like a mathematically mature way, right? Where instead of just P for parentheses, there's grouping symbols, right? That could be a fraction bar, brackets, braces, multiple different things. So we say it's grouping symbols first. Then E for PEMDAS is exponents. So it says evaluate any term with exponents. Then 3 is multiply and divide in order from left to right. And then 4 is add and subtract in order from left to right. So PEMDAS, PEMDAS. Okay, so let's look at number 4. So according to PEMDAS, first thing we're going to do is anything that's in parentheses or other grouping symbols. So that is 7 minus 2, which is 5. Okay, so I did within that parentheses first, 7 minus 2 is 5. So the next thing is evaluate any terms with exponents. So I have 3 to the 4th power. So I need to figure out, well, what is 3 to the 4th power? So I'm getting some scratch paper here. Okay, 3 to the 4th power means 3 times 3 times 3 times 3. So let's look at what that is. 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 is 81. So that gives us 81 times, okay, and then I have 5 to the 3rd power. So that means 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. So it's a pretty big number, right? I have to do 81 times 125. So I'm going to stack them on top of each other. I put the 3-digit number on the top. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. Put a 0 to show I was there. 8 times 5 is 40. 8 times 2 is 16. Plus 4 is 20. And then 8 times 1 is 8, plus 2 is 10. So I have 5, 2, 1, 0, 1. Okay, so 10,125. They're not all going to be that big. Let's look at number 6. Are there any parentheses that I need to do first? No. So I'm going to move down to exponents. 3 squared means 3 times 3, so that's 9, plus 5 minus 2. Is there any multiplication or division? Nope. Is there any addition and subtraction? Yes. 9 plus 5 is 14. 14 minus 2 is 12. So that's a big difference from this one, but same process. Okay, let's look at this one. I have 3 squared plus 5, that quantity, minus 2. So according to PEMDAS, right, order of operations, we're going to do within my parentheses first. And within that parentheses, I have to follow PEMDAS. So I have to do this exponent first. 3 squared is 9. So now I have 9 plus 5 in my parentheses, minus 2. 9 plus 5 is 14. 14 minus 2 is 12. So let's look at that. We got the same answer as up here, right? Because you are going to do that exponent first, even if it's in parentheses. Okay, number 7. This one, I have to do the parentheses first. 3 plus 5 is 8. And then I have 8 squared minus 2. So what does 8 squared mean? Let's think about it. That means 8 times 8. So that's 64 minus 2, which would be 62. Okay, so now let's talk about this bottom section. It says the expression negative 5 to the 4th and the quantity negative 5 to the 4th are not equivalent. The expression negative 5 to the 4th means the opposite or the negative of 5 to the 4th. So the base of 5 to the 4th is 5, not negative 5. Okay, so you're like, what did you just say? Okay, here's the difference, okay? Negative 5 to the 4th. What this means is it's like saying 5 times 5 times 5 times 5. We're going to do that, and then we're going to take the opposite of it. Okay, so it's going to be negative 625. This one, with the parentheses, means I'm taking the whole thing, negative 5, and I'm raising the whole thing to the 4th power. So positive, right? Negative and negative is positive. Negative and negative is positive. This one would be positive 625. So what you have to remember is that if it's not in parentheses, the exponent is only touching this number here, okay? So let's do a couple examples and hopefully that'll kind of clear it up. So on this one, it's the whole quantity, negative 2, being raised to the 3rd power. So it means negative 2 times negative 2 times negative 2. Negative times negative, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 would be negative 8. So let's look at the next one. On this one, it's saying the opposite of 2 to the 3rd power. So we're going to do 2 to the 3rd, which is 2 times 2 times 2, and then we're going to take the opposite of it. So 2 times 2 is 4, times 2 is 8, and it's negative. Okay? So let's look at this one right here. Okay, same thing. The exponent is only touching the 3. It's like saying the opposite of 3 to the 4th. So the opposite of 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And it's negative. But then this last question, it's the whole quantity, the whole parentheses being raised to the 4th power. So negative 3 times negative 3 times negative 3 times negative 3. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, but let's look at the negatives. These two make a positive, these two make a positive. So it's positive 81. So what's the difference between, like, why did the parentheses here make one negative, one positive, and over here it didn't make a difference? What do you think? It's because this had an odd exponent. So it didn't matter if it was being multiplied by a negative, right? It's going to be 3 times a negative, which is going to be a negative. Over here, because it was an even exponent, right, we ended up with a positive instead of a negative.